In section 11.3, we are going to look at what is called implicit differentiation. An equation that's written in the form y equals 2 minus 3x squared is written explicitly as a rule to determine y for each x. You are told y equals. You would plug in a number for x and you would be able to figure out exactly what y equals. If we take that equation and rewrite it so that it's written in the form 3x squared plus y equals 2, it's the same equation, but it doesn't state explicitly how you find y. It's implied, but it's not an explicit rule that you have to take 3 times the x that you square and then subtract that from 2. We need to learn how to do implicit differentiation because there are some equations that are very difficult or even impossible to solve for y. An example of that would be the equation x squared y to the 5th minus 3xy plus 5 equals 0. It would be very, very difficult or impossible to make that say y equals. The steps that you are going to follow when you use implicit differentiation are as follows. You are just going to find the derivative of each term using the rules you already know. We have no new rules in this. What's different is when you take the derivative of a y variable, you do so using the rules you already know, but as soon as you finish your derivative, you write y prime right after it. After you go through and do the derivative of each term, you simplify the terms or combine any like terms as needed, and then you solve your resulting equation for y prime. So let's start learning how to do implicit differentiation. On our first example, we have the equation 3x plus 5y plus 9 equals 0. So we are going to do the derivative of each item using the rules we already know. Well, the derivative of 3x is going to just be 3. The derivative of 5y will just be 5. But anytime your variable is y, after you do the derivative, you must write y prime. The derivative of 9 is 0, and that equals the derivative of 0 is also 0. There are no simplifications or changes we need to make to this. We just need to jump down to solving for y prime. So I need to get the y prime term by itself. If I do that, I'm going to have 5y prime equals negative 3. Divide both sides by the 5, and we get y prime equals negative 3/5. So that is the derivative of that equation. What I want you to see is that that equation could easily have been solved for y. We could have made that 5y equals negative 3x minus 9, and then divide everything by 5, so we would have y equals negative 3/5 x minus 9/5. Now, if I do the derivative of that, y prime would equal the derivative of negative 3/5 x is negative 3/5, and the derivative of 9/5 is 0. So we did get the same answer. So you can see that this technique does work. On our second example, the equation is 3xy minus 2x minus 2 equals 0. You will see a lot of problems like this one where we have two variables in the same term, the xy combination like that. When you see that, you must use the product rule on that item, where 3x is the first and y is the second. So let's put that into practice. I'm going to put the product rule in a set of brackets just so it's set aside and you can see where it was happening. If 3x is the first, we're going to keep it as it is. The derivative of y would be 1, but that was a y, so we have to write y prime. Plus the second as it is times the derivative of the first would just be 3. So that ends where we are using our product rule. Now go on and do the derivative of the rest of the terms. The derivative of minus 2x will be minus 2. The derivative of minus 2 would be 0, and the derivative of 0 is also 0. So we are going to clean up what we've got going over here a little bit, just to make it prettier and easier to read. 3x times 1y prime would be 3x y prime. 3 times y would be 3y, minus 2 equals 0. Now we need to solve what we have for y prime. So we're going to get the term with y prime in it by itself. We're going to leave it on the left and move the other two terms to the right. So I will have negative 3y plus 2. I need to divide the y prime term by 3x to get it by itself, which means I also have to do that on the right side. So y prime equals negative 3y plus 2 over 3x is your answer. Do not simplify or cancel those 3's. The items in the top are being added, not multiplied, so you cannot cancel. The equation on example 3 says x cubed minus 3y equals e to the y. The derivative of x cubed is 3x squared. The derivative of 3y would be minus 3, and since that was a y, we have to write y prime, equals. Remember that the derivative of e to the x is just e to the x. So the derivative of e to the y is just e to the y. But because it was a y variable, we must write y prime. This is the first case where we've had a y prime on each side of the equal sign. So we need to get the y primes on the same side of the equal sign. I am going to move the negative 3y over to the other side just to make it positive. It makes my life a little bit easier when things are positive. This would give us 3x squared equals e to the y prime plus 3y prime. Notice that there's a y prime in both terms on the right side. So we're going to factor that out. If we take y prime out of the first term, we're going to have e to the y left. And if we take it out of the second term, we're going to have 3 left. So how do I get that y prime by itself? Well, I would divide by the quantity. So my answer comes out to be y prime equals 3x squared over e to the y plus 3. On example 4, where we have the equation of y minus xy squared plus x squared plus 1 equals 0, notice that we have another one of those terms with both variables in it. So this means that we need to use the product rule on that term. The first term, as we start it, will be the derivative of y, which is just 1, but because it was a y, we have to write y prime. minus. Now here's where my product rule comes into play, is after this minus. First is x. The second is y squared, so the derivative would be 2y. It was a y, so we have to write y prime. Plus, the second is y squared times derivative of the first is 1. That ends our product rule for that second term. Moving on, the derivative of x squared is plus 2x. The derivative of 1 is 0, and it equals 0. So there's a couple things we need to do to clean up a little bit. First of all, 1 times y prime is just y prime. We have to distribute this negative to both of the terms inside the brackets. And we're going to clean them up a little bit. So we're going to have minus for the first term, 2y times x gives us 2xy. We always write the y prime on the very end. Minus 1 times y squared gives me y squared plus 2x equals 0. We need to get the terms with the y primes, there are 2 of them, on one side and everything else on the other side. The y primes are already on the left, so I'm going to leave them on the left and move the other items to the right. So I would have y squared minus 2x in moving those to the right. Just like on the last problem, we have a y prime that we can factor out. If I take the y prime out of the first term, what's left is 1. Take it out of the second term, what's left is 2xy equals y squared minus 2x. To get the y prime by itself, I'm going to divide by the quantity on both sides. So y prime will equal y squared minus 2x divided by 1 minus 2xy. You cannot simplify those two x's because they are being subtracted from the other items. That is your final answer. For example 5, we have the natural log of x plus 2y squared equals 4x cubed. Remember that the derivative of the natural log is 1 over the argument times the derivative of the argument, which is just 1. So the derivative of the natural log of x is just 1 over x. Moving on to the next term, the derivative of 2y squared would be 4y, but because it was a y variable, we have to write y prime equals the derivative of the 4x cubed is 12x squared. To finish this, we need to get the y prime by itself. So I'm going to leave it on the left. 4y prime equals 12x squared minus 1 over x. In order to solve this and make it a relatively pretty answer, I'm going to create a single fraction on the right. The common denominator would be x. So I am going to take the 12x squared times x over x. This would give me 4y prime equals 12x cubed over x minus 1 over x. But now I can write that as one fraction. So I'm going to have 12x cubed minus 1 over x. To solve this, we need to divide by 4y on the left side. But we've already got a fraction on the right side. So rather than taking a fraction and dividing it by something, I'm going to use the other idea that dividing by is the same thing as multiplying by the reciprocal. So I'm going to take both sides times 1 over 4y. Now the 4y over 4y cancels, and we're left with y prime equals, on the right-hand side, you need to take the two fractions times each other. So you need to take the top times the top. 12x cubed minus 1 times 1 gives us 12x cubed minus 1 over, on the bottom, x times 4y would be 4xy. On example 6, we are to find the derivative and then evaluate the derivative at the indicated point. The function we are given is x squared y minus 3x squared minus 4 equals 0. The point we are given is 2, 4. Notice that we have another multiplication of xy, so we have to do product rule again. So the first is x squared times the derivative of y would be 1 y prime plus the second y times the derivative of the first, and the derivative of x squared is 2x. So that's the end of the product rule. Now move on and do the rest of the terms. The derivative of minus 3x squared is going to be minus 6x. Minus 4 is 0 equals 0. Just prettying up the first two terms, we're going to have x squared y prime plus 2xy minus 6x equals 0. We need to get that y prime term by itself. So we're going to leave x squared y prime on the left side. Move the other two terms to the right side, which will give us positive 6x minus 2xy. Now we need to divide both sides by x squared. So we're going to have y prime equals 6x minus 2xy over x squared. This can be simplified because there is an x in every term. So take one x out of every term, you would have 6 minus 2y over x as the simplified version of the derivative. So we found the derivative, which was the first part of the directions. Then it says evaluate at the point. So we want to know, what will y prime equal at 2, 4? Plugging those in, we're going to have 6 minus 2 times the y is 4 over the x, which is 2. So we get 6 minus 8 over 2, which is negative 2 over 2, which is negative 1. For example 7, we want to find the slope of the graph at the given point. Slope of the graph just means find the slope of the tangent. It's the same idea, but that still means that we need the derivative. Notice that we have both x and y in the second term, so we're going to have to do product rule again. Starting off with our first term, the derivative of 5x squared is 10x minus, here's where I'm going to start my product rule. The first is 6x times derivative of the second is 1, but it was a y prime, plus the second y times derivative of the first will be 6. So that ends the product rule for the second term. Moving on, the derivative of y squared will be plus 2y, and that was a y, so we have to write y prime equals 0. We need to distribute our negative and clean up the terms a little bit. So we're going to have 10x minus 6xy prime minus 6y plus 2y prime equals 0. We need to keep the y prime terms on one side and move the other terms to the other side. So we're going to have negative 6x y prime plus 2y prime equals 6y minus 10x. Factor out the y prime on the left. You will be left with negative 6x plus 2y inside equals 6y minus 10x. Divide by the quantity to get the y prime by itself, and you will have 6y minus 10x over negative 6x plus 2y. Those numbers are all even, and they would all divide by 2. So our simplified version would be 3y minus 5x over negative 3x plus y. Now that we have the derivative, we need to find the slope of the graph. That means plug in the values 1 and 1. 3 times 1 minus 5 times 1 over negative 3 times 1 plus 1. This will give us 3 minus 5 over negative 3 plus 1, which is negative 2 over negative 2, which equals 1. On the last example, we are asked to write the equation of the tangent line to the graph of the function at the given point. So this time we want to go all the way through to the equation of the tangent line, but we still need the derivative. And notice that this first term on the left side has both a y and an x in it. So it will require the product rule, where y is the first term and e to the x is the second term. Doing that product rule on the left, first y times the derivative of e to the x is e to the x, plus the second e to the x times the derivative of y is 1, but it was a y, so we have to write y prime, equals the derivative of y squared is 2y, and we have to write y prime, plus the derivative of x is 1, and the derivative of the minus 2 is 0. So now we have y e to the x plus e to the xy prime equals 2y y prime plus 1. You don't have to do that rewrite. If you can see everything well enough in the way you wrote it originally, that is absolutely fine. But notice that we have two different terms with y primes in them on opposite sides of the equal sign. So I am going to get the items with y primes on the left and the non-y prime items on the right. That will give me e to the x y prime minus 2y y prime equals 1 minus y e to the x. I need to factor out the y prime on the left, which would leave e to the x minus 2y inside the quantity. Divide by the quantity to get y prime alone. So your final answer for your derivative will be 1 minus y times e to the x over e to the x minus 2y. Now that we know the derivative, we need to find the slope of the tangent line. And remember that the derivative is the formula for slope of the tangent. So we need to put the point 0, 2 into our derivative. We would have 1 minus y is 2, e to the x is 0, over e to the 0 minus 2 times 2. Well, e to the 0 equals 1. So we would have 1 minus 2 over 1 minus 4, which will give us negative 1 over negative 3, which becomes positive 1/3. Now we know the slope of our tangent is 1/3. We need to write the equation of the tangent line. So going back to that point slope formula, y variable minus the y of our point was 2 equals our slope of 1/3, x variable minus the x of the point was 0. Y minus 2 equals 1/3 x. Finish it off, y equals 1/3 x plus 2. And that is the equation of your tangent line.